Why are divisibility rules related to number bases? Imagine trying to find patterns in numbers that help you tell if one number can be divided evenly by another. It's like discovering secret codes hidden in the way numbers are written. Now, have you ever wondered why these rules seem to change when you switch from one counting system to another? Well, it all comes down to how numbers are represented in different number bases. Number bases, or radices, are the systems we use to write numbers. The most common one is base 10, which uses 10 digits from 0 to 9. But computers often use binary, which is base 2, or hexadecimal, which is base 16. Each base has its own set of digits and its own way of assigning value to each position in a number. For example, in base 10, the number 123 is written as 1 to 3, which means 100 plus 2 tens plus 3 ones. In base 2, that same number is written as a series of zeros and ones, representing powers of 2. Divisibility rules depend on how numbers are broken down into these place values. For instance, in base 10, the rule for checking if a number is divisible by 3 involves adding all its digits. This works because powers of 10 leave a remainder of 1 when divided by 3. So, the sum of the digits gives the same remainder as the original number. But in other bases, these rules change because the way powers of the base behave modulo a divisor is different. Take base 12, for example. The rule for divisibility by 11 involves summing digits, just like in base 10. This is because in base 12, 11 is related to the sum of digits in a similar way. In base 10, the rule for divisibility by 11 involves subtracting and adding digits alternately, because powers of 10 alternate between 1 and -1 modulo 11. This pattern is based on how the base interacts with the divisor. So, the reason divisibility rules are connected to number bases is because these rules relying on the properties of the base's powers when divided by a certain number. The way digits are weighted depends on the base, and the patterns that emerge are tied to how these powers behave in modular arithmetic. This is why rules for base 10 have analogs in other bases, often involving sums or differences of digits related to the base. Understanding this link helps us see why divisibility rules work across different numeral systems. It also explains why some rules are simple in one base but more complex in another. Whether you are working in binary or hexadecimal, the underlying principles are the same. They all depend on how the base's powers behave when divided by the divisor. This connection makes number theory more visual and tangible, showing how the way we write numbers influences the rules we use to understand them. It's a fascinating way to see the hidden structure behind the numbers we use every day.